This home lab took me 15 years to build, and I've made so many mistakes along the way. If I would have to start over again, I would do things so much differently. And I wasted so much money. I want to tell you how to prevent making those same mistakes if you're getting into electronics. To a point where my wife challenged me recently to estimate how much money I have spent on this office, on this home lab. And the number, it's actually pretty wild. So stay towards the end of the video and I'll tell you exactly how much all the tools over the 15 years cost me. So let me walk you through the lab. Let me show you the tools I wish I got sooner and the tools I've wasted so much money on, so you do not make the same mistakes. It'll be a wild one, so strap in. Oh, and by the way, I'm giving away this 3D printer right there. It's the Adventurer 3. Stay tuned. I'll tell you somewhere in the middle of the video on how you can win it. And trust me, the chances are actually pretty high. So let's move on. First of all, I need to tell you a little bit about what type of projects I make here. I mainly focus on embedded systems, or in other words, electronics that have some sort of a microcontroller in them. I designed my own injection molded cases. I have done obviously 3D printed stuff. I make electronics, I write the firmware. I go into depth with electronics. That's my main thing. By the way, I've made quite a few things over the years. I'm gonna release a video on this towards the end of the year, so stay tuned. I've spent a lot of money making this. Way too much, way over budget, and that's a whole story. But subscribe if you don't wanna miss that. Let's dive into the lab. Let me show you my first machine, and I'm gonna save this one for a little bit later. This is the tool I use probably the most often. It is a tool I wish I've gotten so much sooner. It's not cheap, but it is amazing if you're working with electronics. If I need to inspect anything, a PCB of any sort, especially when you're dealing with tiny little surface mount components, it is brilliant for that. Now, that said, is it necessary to start with? No, absolutely not. You can use one of these. Well, let's see if that shows up. There we go. You can simply use a magnifying glass to start with. It is absolutely, it's pretty cool. It is absolutely not necessary to use a microscope. That said, I've used one of these, actually a jeweler's loupe to be specific, for years. But ever since I got my hands on this microscope, it has been a game changer. You can see so much more detail. You can inspect so much more. You can check if your 0402 tiny little capacitor that you can barely see with your eyes is actually properly soldered. You can solder wires as thin or thinner than your basically the width of the hair. It is absolutely crazy and it is amazing. That said, do I recommend it for someone that's just starting out? No. Use one of these. I hope that came out. Or these. Just use a loupe. You don't need an expensive, fancy microscope to start with. That said, if you are very, very serious about electronics, it is a game changer. And I highly recommend one then. This is something I wish I bought way sooner, and oh boy. When I started, I got a $15 soldering iron, and that was a big mistake. I wish I spent a lot more money on a soldering iron back then. Now the TS100 I'm holding here did not exist back then, but temperature control on an iron, it is unbelievably useful. Being able to quickly change out the tips and really have high quality tips is a game changer. Seriously. It warms up so quick, cools down very quickly too, and it just lasts. This iron, I'm not sure even how old it is at this point, but it's been through hell, as you could tell. My kids have dropped this as well. Not hot, don't worry. But it's been dropped so many times, and yet it's still working perfectly fine. It's time for an upgrade. Don't get me wrong, it's beat up, but my goodness, I wish I bought this much earlier. So if you're getting into electronics, spend the money on a soldering iron. It is absolutely worth it. And to be honest, these days, these guys are pretty cheap. Back in the day when I was starting, yeah, it was very expensive to get a good quality soldering iron. But today, you've got companies that produce things like this. They're open sourced actually, which is kind of cool. Get a proper iron. That's all I'll say out there. And since we're talking about soldering irons, I highly recommend getting this copper mesh thing for cleaning tips. That way, when you're cleaning the tip, you're not using one of the chemical ones. Do I have one? Yes. Oh man. Whatever you do, do not, and I repeat it, please, I beg you, do not get a tip cleaner. These things eat your tips. They smell horrible and they literally just chew your tips. Speaking of smells, I wish I've gotten one of these so much sooner. This is a carbon-based filter. It's an air filter. It's basically just a fan with a carbon filter in front of it. What it does is it takes all the fumes of solder. Anytime you're soldering, you're producing fumes, you're producing VOCs, harmful VOCs. It takes the smoke, filters through carbon, and takes out majority of the bad VOCs in the air. You literally see the smoke disappear. It's pretty cool. Is it a must? No, it is not a must. You could just open windows and solder in a well-ventilated area, especially if you're just starting out. But if you want to work in an enclosed area just like this, it's super hot here right now in Texas, and I don't want to open my windows. So if I don't want to open my windows, this does the job perfectly. And by the way, that's the reason I actually designed one of these. This is a VOC sensor. I'll talk about this in a future video, so subscribe. But highly recommend one of these if you're going to solder. Necessary? No, but I highly recommend one anyway. Okay, and since we are talking about soldering, let's talk about this beauty right here. This is a 3-in-1 surface mount hot air station. What it is useful for is basically anything to do with surface mount components. A soldering iron and a hot air station is absolutely a must. These two will get you so far in electronics, and it blows my mind that people are scared or unaware maybe of these things. You could use it to reflow your boards. You literally can just use this instead of using a hot plate or anything else to solder your surface mount components. You can use it to fix your surface mount components. You heat up the board and you simply lift up your components. It is brilliant, it is great. Highly recommend. Now, if you are going to get into surface mount components, I do recommend a low temperature surface mount paste. I could get into that in another video. And for soldering, use good flux. Those two. One more thing, actually. And use silver-based solder. These things are pretty cheap these days. So is this necessary for anyone that's starting electronics? Yes, absolutely. Either starting or a pro, you absolutely need one of these. This is a must. It is something actually I got really early on as well. So absolutely yes. And since we're talking about surface mount components and soldering, let me show you my reflow oven. Now, this is definitely an overkill for majority of people, especially if you're starting out. Do not get one of these, but oh my, this thing has been so great, especially paired together with my Pick and Place. I assemble my PCBs, trial runs, whatever, place them in, boom, run it. 5 minutes later, 10 minutes, whatever the reflow profile is, comes out perfect every single time. So yes, I highly recommend this for anyone that's really serious about electronics. And to be honest, well, all of these tools take space, right? If you're just getting started, no, don't get it. No, there's no need. Just use a hot air station. That's all you need. But if you're very serious about electronics, definitely recommend one of these. And since we're talking about surface mount components, let's address the elephant in the room. Now, I do have a full dedicated video to this machine, but the summary, I love it. It is a speed hack. Is it something that you should get if you're a beginner or starting with electronics? No, absolutely not. Even if you are really into electronics, to be honest, this probably is a bit of an overkill. Watch the full video on my channel at the end of this video, not before, because you still gotta know how much all of this cost. So let's move on. I wanted to learn how to do injection molding, and what better way than to design your own molds like this one here and buy an injection molding machine. Yeah, this is by far the biggest regret I have. Now, don't get me wrong, this machine is actually pretty good. For what it does, it is perfect. If you want to learn how to do injection molding, if you want to do your own molds, if you want to learn how all of that functions and works, amazing, great. This machine worked really well. That said, I haven't used it for about 5 years, and it cost an arm and a leg. Do I recommend it? No. To be honest, even if you're serious about electronics and really want to make really polished projects, no, unless you're trying to learn how to design your own molds, and not even injection molding plastics or whatever. There are better ways to do that nowadays. If you want to do your own molds, yeah, sure, maybe, then probably get one of these. For education purposes, great. If you want to produce anything, absolutely not. That's what I thought I would be able to do. Let me put it this way. In order to do a single mold, it took about 20 minutes of work. Anyway, it is super hot in here. Let's go back to the office. So let's talk about these two beauties. And oh my, I got into 3D printing quite a bit late in the game, to be honest. And I wish, and I really wish I literally got into it as soon as the first 3D printers came out, because oh my, it changed the game completely for me. Enclosures, making things out of 3D is just so much fun. 3D printers are high on the list of things I would recommend for anyone. And by the way, if you want to win this very 3D printer, it comes as is, but it works. I've used it till yesterday, actually. If you want to win this 3D printer, sign up for the mailing list. There's a QR code somewhere on the screen right now. Plus, hey, if you sign up for the mailing list, you'll get really cool updates once in a while from me. As I go and as I do things, as I discover things, I sometimes send an email. I don't spam, I promise. So, that said, moving on. Let's go back to the garage, because that's where I have my stinky printers. But they're pretty good as well. Let's go. I love 3D printing. I do not enjoy SLA printing, but the quality of the parts that you get, the detail that you can produce, it is unbeatable. I recently did a test with a 0.25 millimeter nozzle in the best settings on my 5M Pro, and it is simply impossible to beat SLA. So if you need really high quality, small parts, these are amazing. If you need high precision, SLA is the way to go. Is it beginner friendly? No, not really. Unless you are into making tiny little models and things of that nature, I would not recommend one of these. So if you're a beginner and just starting out, don't get it. Get an FDM printer first. And then if you really need that extra resolution, that extra quality, yeah, these are awesome for that. But only if you really need that. The other good thing about SLA is that you could produce 100 parts all at once, because for an FDM printer, it's got to make that path for every single little part. Here, well, it's a blanket cover. So if you could fit 100 parts onto the bed, you'll make 100 parts in one go. And it will take the same time that it takes to make a single part, which is pretty cool. Okay, right here I have a CNC machine that I really wish I did not purchase. It was not super expensive, but boy, oh boy, I wasted my money. Now, if you want to carve things in wood and carve things in, I don't know, super soft plastic, yeah, this will do the job. But don't waste your money on a cheap CNC machine. I cannot recommend this, that's for sure. And since we're talking about cutting, let's talk about the Cricut. I've got the Cricut Maker 3, which I have used extensively on the Micro Eraser project. I've cut out shapes just like this out of different materials. This one is actually a magnetic sheet, very thin 20 mil magnetic sheet that the plotter was able to cut through and make the perfect shapes for the project. And by the way, I've got the Micro Eraser project now on sale. So if you want to check it out, click the link in the description below. Do I recommend this machine for anyone that's starting out? Not really. If you're into electronics, I don't think this is as useful. Now, if you want to make stickers and cool decorative stuff, you could cut out your own decals and things of that nature. Yeah, it's actually pretty cool. Right, so now let's talk about the oscilloscope. There's probably a great myth, or maybe I'm just making this up in my head, that an oscilloscope is a must for anyone doing or getting started with electronics. Let me put it this way. No, not at all. Let me show you why. For the majority of the purpose, majority of the work that I do, for simple verification stuff, this is enough. This is just a simple voltmeter. Now I've got a Fluke because, well, I am into electronics heavily, but, and again, I've built out this whole thing over time. It's not like I've just gone on a shopping spree. I wish. Anyway, an oscilloscope is absolutely great. Yes, for sure. That said, I find myself using it very rarely. I basically use it towards the end of the project, meaning if I want to take the actual project from a prototype to a product, this is extremely useful. You probe all of your lines, you make sure there's no ripples, there is no noise, all the voltages are stable and everything looks pretty, right? That way you know that you're going to pass RF, or rather have a better chance at passing the RF emissions in testing, FCC, CE, all this stuff. Is it necessary at first? No, it's not. If you're seasoned and you really are serious about electronics, yeah, definitely. Now, I don't have an expensive oscilloscope. This thing was not crazy money. I was broke back then, but it's actually still perfectly enough for what I do even today. Do you need a voltmeter? Yes and yes. This is a must. You have to be able to check and verify that your voltages are correct. You want to be able to see if that I/O is in a high state or a low state, depending what it's supposed to do. If it's logic, then it's a different story, but we'll get into that. Now, over the years, I've had many different logic analyzers. And to be honest, oh boy, I've spent a lot of money on logic analyzers and I've bought many cheap ones over the time. And I highly recommend just simply getting a good one. They're not cheap, but a logic analyzer, majority of the time, can even replace your oscilloscope. Now, if you have communications such as I2C, SPI, or anything else within the board, so if your microcontroller is talking to an external peripheral, this becomes extremely, and I mean extremely handy. 100% recommended. Now, do you have to go expensive? No, don't. That's fine. But if you do, I recommend having a good logic analyzer. And if you're debugging circuits quite a lot and you do all sorts of different designs, I've found this to be actually super helpful. This is a FLIR camera. It's basically an infrared camera. There are cheaper alternatives nowadays, but I wish I've gotten this sooner. Anyway, this allows you to really pinpoint exactly where the problem on a PCB is coming from. Whether it's a failed component that's just simply overheating, or if it's a component that you installed incorrectly, this is a savior. Now, do I recommend this for someone starting out? No, don't do it. You could just simply feel out the board. You will burn your fingers, so careful. But you can just hover your hand over the board and really feel where is the heat coming from, and then, you know, disassemble that portion of the PCB using your hot air station. So if you are serious about electronics, and if you really are serious, yes, it is a great tool. I've used this so much. I recommend it for sure. Now there's one tool that I almost forgot to mention, and it is probably actually the most expensive tool in this entire office. Can you guess it? It's my PC. I have a laptop, but majority of the time, most of the work I do on a standalone tower PC. I've built this thing over the years, and I have upgraded it again and again and again, so I'm not sure even how to even estimate how much money I've spent on this. In the current form, it's more or less around $3,000 for the PC alone. Now that's of course new, not deprecated over the last 2 years or whatever, but it is a mind-blowing amount of money. That said, a PC, especially if you're doing any sort of CAD work, be it Fusion 360, CAD modeling, whatever, KiCad meaning PCB design, or anything else, you need a good PC. And now, since I do YouTube, well, in order to render these 4K videos that I'm producing, hey, it's absolutely necessary. So, subscribe. No, joking. Anyway, now for the grand reveal, finally, let's talk about how much this whole entire place cost. I just finished the count, and oh my, the total comes out to $9,039, and that's not even counting things like debuggers, calipers, and so forth. Small things. Well, actually, the debuggers are fairly expensive. This one's probably like $200. If you like this video at all, consider subscribing, and I will see you in the next one. Thank you so much. Bye-bye.